Could you give me a little background here, Noah, in terms of who you are and what we're looking to do here today, so I
Ab-
can?
Absolutely. Okay, so I have two companies.
Okay.
One company is a media company called Today's Machining World.
Okay.
We're a blog. We started as a magazine, a B2B magazine for the machining industry. We've been around almost 20 years now.
Kind
Um,
of like modern machine shop.
yeah, they're a competitor of ours.
Okay.
And but
It-
they're very advertorial, and
right.
so we you know we don't pander to advertisers. We're very we basically talk about whatever we feel like talking about, whatever we feel like our readers would be interested in,
Okay.
be it sports or philosophy, etc. And we just started this podcast about 2 months ago. And the other company we have is a used machine tools business called Graf Pinkert. And uh, I got a call from Ben, or an email from him, because you guys were looking at a Traub machine. I think he was just trying to price price one, but we had this Traub TNL 18 in Spain that we've been trying to sell, and
Okay.
he wanted to know how much it would cost, and that's how I discovered you guys.
Oh, interesting.
Yeah, I know, it's funny. The two businesses, go well together because it's it's the perspective of a machinery dealer, somebody in the industry, not in the industry like you, and that we're not making parts, but we're still immersed in all of it. So that's the story. I found your company and then watched some of your videos, and it's a topic that I found interesting. So I thought it would be a great podcast. We've done about 13 or 14 so far, and
Okay.
so that's
Where,
where I'm at. Do you have any other questions?
yeah, where are you based out of, Noah?
We're a southern suburb of Chicago,
Okay, cool.
but I know Madison well because it's my alma mater.
Nice. Well, you could stop by for a visit sometime too if you like, 'cause we're not that far away.
I would love to stop by for a visit.
'Cause, things are about to get a little bit more interesting here because we actually ended up purchasing a TNL 18 right from Index,
Right, right.
and hopefully it'll be delivered here beginning of November. So we'll have that on the floor to kind of join some of the other CNC equipment that we have. So
Well, I said to Ben, I said, we, your, I mean, your product looks really great, but I mean, this is a powerful uh, machine. This is like, the Lamborghini of Swiss machines. You're using
it does,
Ganeshes, and no offense to Ganesh, but I mean, it's like going from a Hyundai to a Lamborghini.
and that's exactly where we want to take our whole product line. Is the whole impetus to create our devices was to make something that's very robust and reliable,
Hmm.
simple to use, and durable, right? But at the same time, let's just not make a simple cylindrical tube that anyone with a two-axis CNC lathe can make. That's boring. That's not interesting, and it's way too easy to replicate.
Hmm.
Let's take some of the revenue that we're creating by doing this, and create an ongoing evolution of what it is that we're making, and really start to see what we can do in terms of pushing the limits of our mechanical design and technology to make some of the highest quality products that we possibly can, and really push the evolution as
You
far as.
and you really thought that the Traub was necessary to do that. I mean, I know Swiss to some extent, but I know that what is the advantage? They can do really hard material.
It's not just hard material; it's complex.
Yeah,
Okay,
yeah.
and so if we think about an example of something that's mechanically complex, right? Take a Swiss watch for example, right? You don't make Swiss watches on cheap, simple, inexpensive, low-cost, non-precision machines. You make them on extremely high precision,
That
very
is
complex, very capable machines, and that's a big part of the reason why they're very difficult to mass produce unless you have access to that type of manufacturing infrastructure.
that is true. They
And
use indexes in the Rolex factory.
right, and that's the direction that in my mind, is the direction that we want to go as we begin the transition with this first TROB. I don't know if we'll end up with a second TROB or if we'll make the jump into an index before that happens, but we're really hoping that our next machine purchase is going to be either another TROB or an index next year, and kind of continue in that direction where we can be making extraordinarily complex components for our devices and really kind of pushing the limits of a mechanical vaporizer.
Okay, well, before we go any further, just want to thank you for coming on the podcast, George.
Sure.
And I'd like you to first tell our audience in a nutshell what you guys are making, what DynaVap makes. Did I pronounce the company right? DynaVap? Or DynaVape?
Well, we prefer DynaVap, considering that our devices contain no electronic components. So it's kind of a vape without an E, therefore it's VAP.
Okay.
So I don't know if that helps clarify.
Good. So I got it right. Tell everybody the nitty-gritty of DynaVap.
Okay. DynaVap is a company that specializes and focuses on the manufacture of battery-free vaporizing devices and equipment. So our devices are, I'd almost say, deceptively simple in terms of design, are also very user-friendly in terms of operation, where all you need is some available heat source of sufficient intensity to raise the temperature of the vaporization chamber above the, we'll call it the vaporization temperature of the active compounds you're looking to extract.
Well, tell everybody what it does.
What it does? Oh,
let's start from the very beginning.
So from the very beginning is
what is it for?
What's it for? Well, it's for a wide range of different purposes, and I hope you can understand that there's certain things that need to just be a little bit nebulous about because of various things in we'll call it political challenges that we have in our society, depending on which country or which state you reside in. But as a person that has never been a fan of smoke or smoking, regardless of what it is that you are smoking, I was looking for an alternative, not necessarily for myself, but for the people around me to consume their materials in a, we'll call it, more responsible fashion that would be less offensive to the people around them. Or
tobacco,
whatever,
other substances.
Absolutely, because the thing is, there's a wide range of different materials that a person can effectively vaporize, and not just in our devices, but in all vaporizing devices for that matter. Depending on who makes them and how they're structured, whether it's going to be a plant type material or some type of an extract. There are vaporizers on the market that will effectively vaporize nearly any compound and function as a delivery mechanism that doesn't require combustion extraction. And it's the combustion extraction that we're trying to avoid, because that's where all the incomplete combustion byproducts and a lot of the carcinogens and other, we'll say unpleasant compounds that are really not good for the person that's consuming, and also not good for the people around that person. Smoking. It's so 30 years ago, if you know what I mean. There's no need for it anymore. And, I get that it's popular because it's a very simple, low-tech means of extracting active compounds. But the fact is, there are now much, much better alternatives. But until I think we were able to kind of refine some of our products, most of those alternatives required complex electronics, batteries, power management, and temperature controls, and all kinds of other things in order to function correctly. Mm-hmm. And that, in a nutshell, is kind of the impetus for doing what we did here. And that's to create more of a mechanical analog style vaporizer that will effectively vaporize nearly any active compound out of nearly any available material in a way that doesn't create incomplete combustion byproducts.
So for the people that don't know, the typical vaporizer for smoking runs on a battery. Yes?
Right. Yes, almost all of them. I'd say a good solid 98 to 99% of all the vaporizers produced function either on batteries or a plug-in-the-wall electric heating element.
Okay. Okay. And so the alternative is to heat your device with some other thing, correct? Why don't you give people the nitty gritty on that?
All right. Well, so one of the primary objectives from the initial design standpoint, from the very beginning, was to create a device that would liberate the customer, right, the operator of the device, from the need of a proprietary heat source. Okay, so if it's a battery-powered vaporizer, it tends to have the proprietary heat source built into it, or some of them will utilize, say, an 18650 that you can take out and recharge. But if you don't happen to have an 18650, you don't have a vaporizer. Okay, so our devices, on the other hand, can utilize anything from a lighter to a candle to a stick from the campfire, an electric heating element on your cook stove, and there's even a growing range of other alternatives, including induction heaters, that are showing up on the market and becoming more available. And since all the control is then effectively external to the device, well, you can utilize all of these types of heat sources effectively and consistently because the device has its built-in indicator, but you as the operator are the control.
Okay.
So,
but you have to have some other way to heat it. That's the
yes.
that's the drawback, that you have to be carrying two things with you.
Well, it's either the drawback or it's the advantage, because if you look at a typical electronic vaporizer, okay, if we break apart a vaporizer, and this kind of goes for all vaporizers, you can pretty much summarize them into three constituent components. The first one is, we'll call it the extraction chamber that holds the material that is ready for vaporizing and extraction. Okay. The second is the heat source, and the third thing is the control for the heat source. Okay.
Okay.
All electronic vaporizers have all three of these things combined into one unit. Therefore, when one thing fails, the whole vaporizer fails and is no longer usable. So if your battery goes dead, or if your control fails, you don't have a vaporizer, even though your extraction chamber and the other thing are completely fine.
I
When
see.
we separate the control and the heat source from the actual extraction chamber, now we do two key things. Number one is we put a much more convenient level of control in the hands of the operator. Okay, because now instead of trying to push buttons or turn dials or use a Bluetooth connection through your phone to adjust the temperature settings of your vaporizer, you just change where you're applying heat or how long you're applying heat relative to the indicator on our device. Second to that, the two most failure-prone components of all vaporizers are, probably to no surprise, the heat source and the heat control. And by not having either of those components built into our devices, we're taking those failure-prone components out and leaving the end consumer with a very robust and reliable device that realistically can and probably should last that person and their kids and maybe their grandkids a very long time.
Wow. And basically, and just still, if it physically broke, you're saying that's basically the only.
And that's the other thing, you know, from a physical breakage perspective, it's not something that we have a whole lot of issue with because, you know, our entry-level model, our Model M, retails in the U.S. for $60. I don't think we've received a single return yet from someone that's broken one. Okay, because they're machined from, you know, solid 316 stainless steel. They generally don't break. They're very robust and reliable. About the only thing that ever really wears out are the O-rings, and occasionally if someone's very abusive or complacent, they might step on and crush the cap, or if they really severely overheat it, it'll throw off the calibration, which now it doesn't indicate at the right temperature. But the cool thing is, you can replace the O-rings quickly and easily, and for not a lot of money, and the cap is not terribly expensive. You know, it's going to run about the same price as a couple of 18650s for a battery-powered vaporizer.
Okay.
So more or less two consumable components, and the rest of the device, you know, should pretty much last you the rest of your life because it's not going to rust, it's not going to corrode, and you can literally drive over these things with your car and they don't break.
Wow. Wow. Well, so it's a great irony that you're using the most sophisticated equipment possible to make a very, very simple product, which makes sense.
It depends if you consider it simple. Okay.
Yeah, explain the process a little bit more. It's probably over my head, but
Well,
people need to know exactly how it
sure.
works.
Uh, you know, let's take a rocket nozzle, for example. Is a rocket nozzle simple? Well, in operation, it's actually very simple. You take a hot gas and you push it through a rocket nozzle, and through a pressure drop, you accelerate we'll just say the molecules in that stream of hot gas to a very high speed. Okay?
Mm-hmm.
Push hot gas through a nozzle and you accelerate them. It doesn't have any moving parts. But is it simple? Well, it depends on how you look at it. The principle of operation is very simple. The dynamics of how it works and how to get the correct geometries in order to make it function, as well as the liquid cooling or the radiative cooling that it needs to have so it doesn't melt itself, that's a little bit more complex. And I don't think our devices are a whole lot different in the regard that when you look at how they actually function, they actually have several key components that are combined and features combined into singular components. You know, if we take the extraction tip, for example.
Do you have it? Yeah, okay, cool. You have it right here.
So I'm trying to keep things in focus. But if we look at their tip here, we're going to see several features. For example, you can see these fins, right? These fins function as a means of minimizing how much thermal transfer we get from our extraction chamber into the rest of the body of the device. In addition to that, if we separate it, what you're going to see is there are O-rings on the end of this tip. Okay, and those O-rings provide several things. Number one, they provide a very simple way to connect the components. Right?
Mm-hmm.
You literally push and twist them together. No threads necessary, so you don't have to worry about cross-threading your components. And in addition to that, the O-rings provide what's called a thermal break, because the O-rings have a very low thermal conductivity, and that stops the little bit of heat that makes its way through all the mass here and across all these heat fins, and minimizes how much heat and temperature rise we get in our body or stem of our device here. Okay?
Okay.
So, moving on, we also have our extraction chamber. Okay? So, our extraction chamber, in conjunction with our cap, okay, so the device is used in this condition. You know, we load our material into our extraction chamber, and we place the cap over the top, and if you've seen the videos, we then apply our heat source to the outside of our cap.
Mm-hmm.
And
so there's two parts. There's a cap, and
yes.
then what's the other part called again?
We call this our tip.
The cap and the tip. Okay.
Yep. And the tip is the entire component here that I just pulled apart, and the extraction chamber is basically we'll call it the opening on the end, with a little screen in the bottom.
And the cap is where you put whatever you're going to vaporize.
Nope. Put that right into here, and the cap simply goes over the top.
Oh, okay.
And so then we use our heat source to apply heat to the side of our cap until we hear the cap click. And so the device, again, doesn't have the control. The operator is the control. And the operator utilizes the indication of the cap that, hey, I'm at temperature, to determine, okay, I'm going to stop applying heat, or I'm going to apply heat for just another second longer to get a little bit higher temperature because it's the first heat cycle, and I haven't thermally loaded my extraction chamber yet. Okay? So once that occurs, then the device can be utilized very analogous to a cigarette.
Describe it to people how long it is.
Our device is 92 millimeters, or about the length of a long or like a 100 or 120 type cigarette.
Okay.
And it's about 10 millimeters in diameter, so a little bit larger than, we'll just say, a standard pen body. So all in all, not very big.
Okay.
And our heaviest device weighs about 20 grams, or about 3/4 of an ounce. So, and that's the heaviest device. You know, our titanium devices, some of them are down closer to 10 grams, and we even have some wood devices that are under 10 grams. So,
interesting.
Very, very lightweight. So that allows for some other usage styles that aren't really available with other vaporizers in the market. For example, you can heat this thing up until it clicks, and you can just put it in your mouth and, take away your hands, because it's just not very big. It's not very heavy. So you then have both of your hands free to do what it is that you want to be doing. until the cap cools down and it clicks or it stops producing vapor.
How long can it last before it stops producing vapor?
It depends a little bit on two factors. So again, this is our stainless steel model, and if I grab this other one here, this is our titanium model. And just because of the mass differential between the titanium and the stainless, stainless one takes longer to heat up, it also takes longer to cool down. So it's a little more user-friendly in a cold and windy environment. The titanium one, on the other hand, has lower mass, so it heats up faster. It also cools down faster.
It's more, just for the people not watching, it's definitely more ornate, too, in how it's in the styling, wouldn't you say? I'm just looking at from...
And this is a big part of the reason why we're looking to evolve our manufacturing process into not just mass production, but high technology, high capability technology to allow us to achieve more complex designs, architecture, geometry, and ideally improved overall operation, because we can now machine in features that are effectively unmachinable without that level of capability.
Interesting. So you can do wood, titanium, stainless, you said?
Yes.
And those are the three choices?
Those are our mainstays. We've made various components out of a wide range of different materials. In fact, the first devices that I was prototyping were primarily constructed from glass.
Cool. Yeah, I saw that in a video. But are you continuing the glass or not really?
The glass has been, I'm not going to say discontinued, but suspended. Because the metal products are so much more durable. And I think that's just a really important feature to have. Because when you're converting your habits from smoking to vaporizing, there's not much that's more unpleasant than I just dropped my vaporizer and it's smashed.
Ugh.
And I'm nowhere near home. In fact, I'm traveling.
And that's the problem with all the other vaporizers, that they break. So it sort of defeats the purpose of your product. Exactly.
They break, or their batteries die, or whatever else might happen. It just becomes a less robust design, and it's a material that isn't near as appealing or durable or robust as making them from wood or, say, stainless or titanium. So not that we won't continue to manufacture a limited number of them. I don't think they'll be a mainstay just for the durability factor.
Well, is there... I'm not an engineer, but, I mean, is there a type of glass that's really durable?
Oh, there sure is.
That wouldn't break, or would that be too expensive?
Wouldn't break? No. More resistant to breakage? Yes. But now the cost factor is going to be on par with the titanium models that we produce.
And how much are those?
Our titanium models are in that $180 to $200 range, depending on their size and some of the features.
Okay. And what are the most popular?
By far, our most popular ones are our stainless models, because there's such a low barrier to entry. At $60 US, you can buy a very functional, extremely durable, very capable vaporizer, and kind of test out, whether or not an analog mechanical vaporizer is going to work for you and meet your needs.
Right, because it's a new thing. So if people are going to experiment, they don't want to blow $180.
Exactly.
That makes sense.
And what we find is that not small percentage of our customers buy our M, try it out, sometimes within a few days, and sometimes it's 6 months later they come back and they buy upgrades. And in the upgrades is kind of a fun thing. Because of the design of our devices being very modular, you can upgrade your device one component at a time. Okay? Because nearly all of the components of our most expensive titanium vaporizer are interchangeable with our least expensive stainless steel vaporizer.
Wow, that's really interesting.
So in addition to that, and here's kind of a similarity. If you're familiar with, I think kind of a fun example, Tesla, they upgrade their car's software over the air automatically for all of their vehicle owners for the entire time that their vehicle is still viable on the road. So with our devices, anytime we come up with a new upgrade, it's our goal to make that component backwards compatible with all of our previous devices. So you can upgrade the one component that has the feature or the new option or the new configuration that you're looking for, and you only have to buy.
And you're constantly coming up with new options for them.
And that's just with our existing manufacturing infrastructure. And as we continue to grow and develop our infrastructure and add new capabilities, both in the CNC world and in other areas as well, I don't anticipate that to stop.
Right. Well, you got me thinking of like the problem of if the products are too indestructible, then maybe people will just buy one and they won't buy any more. But the products aren't expensive enough that people probably would say, "Hey, this one's really cool. I want to." Is that part of the reason the styling has to be cool so people will buy more than one? Sort of like wearing shoes or something like.
Yeah, it's certainly a factor, but at the same time, we don't need to be discriminatory here. If you want to buy our lowest cost model and never upgrade it, well, since the parts are generally compatible, if you wear out the cap or the O-rings, well, those parts are going to be available. You'll be able to keep it functional in operation, as far as we're concerned, for 100 years. Yeah, I see that Swarfcast, huh?
Swarfcast. Do you know what Swarf is?
Well, when I think about Swarf, I'm thinking about basically the leftovers from grinding and
yeah. All right.
Finding particulates.
I'm impressed.
Well, I should know that stuff, shouldn't I?
You should, but I feel like we sell machines all over the world, and I think maybe more Europeans they call it like when they're referring to a chip conveyor. My customers in Spain called it a Swarf conveyor. And I was like, oh, okay. Maybe I don't know, maybe it's an English thing, but yeah, we've Swarf blog has been the name of our blog for ever, and it's just kind of like, yeah, what's going on in the belly, the guts, the dreck underneath the surface. So that's hence Swarf blog and Swarfcast. I'm not sure if it's the right branding, to be honest. We'll see, but
yeah, I guess we'll see. I would normally think of Swarf as being something that would be appealing. It's more of a byproduct.
Okay, so you're saying you think it's a good name?
I got to kind of think about it. Like I said, I think about Swarf as being, what's left over after you've made what you wanted to make, and now you have to decide, okay, can I effectively capture this and recycle it, or does it just simply become something that I have to expend resources to dispose of?
Right. Or do you guys recycle your chips and your oil?
Oh, as much as we can. The recycling oil, and maybe you've got some resources I can be looking into, but for the most part, that just means taking it to my other friend's shop, and he burns it in his waste oil burner.
No, but I mean, there's centrifuges, and you can, like, you can basically squeeze out the oil and then reuse it, and then you can take the chips and sell it or turn it into pucks or...
We only machine with oil, though.
Yeah, sure.
So, getting the oil out is, or getting the oil, the problem that we have, the biggest problem we have is getting the, what do you call it? Getting the whey oil out of the cutting oil.
The coolant out of the cutting oil?
Well, no.
The whey oil?
The whey oil. So the machines that we're using currently, and this is another one of the things that I'm really anxiously looking to upgrade to our Traub, is these Ganesh machines come from the factory set to dispense just a ridiculous amount of whey oil. We're probably consuming over a quart of whey oil a day. And, of course, that just goes right into the sump. So after, a month or two or three, now we've got 10 gallons or 15 gallons of whey oil.
Whey oil.
Of whey oil in our sump of cutting oil. So now our cutting oil, has what I kind of refer to as viscosity creep, and it just keeps getting thicker and thicker and thicker because we're cutting with, an ever-increasing percentage of whey oil.
Huh.
It's aggravating. And
with the Traub, what is the Traub is different?
The Traub has a much better arrangement in terms of its internal structures that allows a little bit of whey oil that is utilized for lubrication of the components, like the ball screws, to not land in the sump. It accumulates somewhere else that it can be disposed of separately.
Yeah, see, that sounds standard to me. Maybe the Ganesh, I'm not that familiar with the Ganesh. I know like more Citizens and Stars, but you guys really went for the top. You didn't go Star, you just went for, I'm sure you did a lot of research on that. But
well, is that your opinion of the Traub? Is that it's kind of a top of the line machine?
My opinion is that look, it's our total bread and butter is multi-spindles.
Okay.
And when people are looking into what kind of CNC multi-spindle to get, we always say Index is basically the gold standard. Some of the other ones, they make good ones, but as far as Traub's, Traub was a separate company, and then it merged with Index, and I know their stuff is supposed to be like top quality, but it's way more expensive than everything else.
It's double the price of the Ganesh.
Yeah, well, the Ganesh is much cheaper. Yeah, but I mean, it's so much more expensive than everything. So you really, I know of lots of medical shops, and you have to have the right application. It just, I don't know. There must be something to it. They sell to some people.
Well, I'm hoping that there is. We're hoping that we're not making a poor move, buying a Traub and then hopefully buying an Index to make our little toys. I think when I was interfacing with some of the people at IMTS here, I think it was a little bit engaging for them to think that, oh, here's someone that's going to be using our machines to make something other than medical parts.
Mm-hmm.
And I think it was very interesting, especially from the consideration that we're going to be flexing the muscles of the machines in a little bit different way, where we're going to be making the part and creating the geometry first and seeing how we can make a very interesting, engaging, and high-precision geometry, and then switching gears and getting some good, accurate measurements and creating a print that fits the part that we just made.
Okay.
So kind of a completely different approach, I think.
Well, I'm sure you've done a lot of research on it, and you've weighed the other builders, right? The Citizens and the Stars and Tornos.
Tornos, right? MDI or DMG Mori and
DMG Mori. And the Traub. What did the Traub give you that those others didn't?
I'd say the biggest thing was capability, and also the way we were able to structure things and utilize the Traub as kind of an entry point into developing not only a manufacturing but a purchasing relationship with Index.
Yeah, well, they're great. They're really great.
And and that's, I've heard that from other people as well, and it's nice to get that reassurance, because really the direction that we're hoping to go is to really scale our manufacturing capability and capacity here in this country. And the only way that I could see to feasibly do that in a cost-effective manner is by stepping into a multi-spindle machine like an Index, like an MS-22.
Mm-hmm.
Because how else do we make a?
So you're gonna make gazillions of them.
Well, I don't want to be so arrogant to say that, but I certainly would say that we aspire to do so. Right? That's, to me, that's it's kind of shooting for the stars to think that, that we could actually justify having a machine that can be making the quantity of parts that, a 6 or an 8 spindle, multi-spindle, CNC machine is capable of doing.
Exactly. The part has to be worth X amount in order to, to pay the, what is a MS-22, about $1.5 million?
Yeah, the MS-22s are going to start, north of $1 million, and depending on how you deck them out, they can be upwards of 2.3 to 2.5
for the 8 spindle. Yeah.
Yes.
For the 8.
They're pretty amazing.
You just need a 6 spindle, though, right?
Well, we're still kind of debating what is going to make the best parts and allow us to really flex our muscles and know where we want to go. Because unlike the Ganesh, where when we were looking at the Ganesh, we were thinking the Ganesh is going to be a 3 to 5 year machine, right?
Mm-hmm.
Where by the time we're hitting the 3-year mark, we've already realized the most significant hit of depreciation, and selling it anywhere from 3 years to 7 years, we're going to get within $10,000 to $15,000 the same price for it used, regardless how many hours are on it. So we want to be able to utilize it to the best capacity in that time frame. But when you're looking at a Traub or an MS-22, you're looking at a machine that realistically you should be able to get a good solid 8 to 12 years of.
Traub was what, about 800?
No, about half that. Because we didn't go with the 11-axis variant, and the new ones that they have, the TNL-20 has a robotic arm option, which adds about another 200,000 to it. Didn't really make sense for us at this point because our parts are small and are generally cut from bar stock, so didn't really make sense. Wasn't a real need for that.
How much were the Ganeshes? I was thinking around 250.
No, the Ganesh machines are even cheaper than that. Loaded up with the bar feed and the fire suppression and everything, high pressure coolant, for machining the titanium. You're looking at under 200,000.
Under 200.
It's still not a cheap machine in comparison to a 2-axis Haas or something like that.
Mm-hmm.
But
did you hire somebody from a pretty experienced setup person or manufacturing engineer to come up with your plan, or
that might have been a good idea, but the answer is no.
Mm-hmm.
What ended up happening is Jason, who you'll meet if you come up here, originally, when I was just kind of getting things going, he was making some parts for me on his old 1952 South Bend lathe.
Wow.
Okay? And when I say making parts, he prototyped some of our first titanium tips and was cutting some of our internal condenser tubes and making some of our wood mouthpieces. This was before I had any employees. Okay, so I was just paying him by the piece to do these things, and I was giving him something to do, and he didn't really have a whole lot going on either. So I appreciated the parts, and he appreciated the work. It was a good deal.
Yeah, it's prototyping, so you don't need a lot.
A lot of that, in we'll call it small scale production, right? So fast forward, about 8 to 9 months later, he decided he wanted to take the role a little bit more serious, wanted to become part of the company, and we started looking at machines. And the first CNC machines we actually purchased were made, or they're not made, they're sold by a company that's right here in Wanakee called Tormac.
Tormac, okay, I've heard of that.
Yeah, so they're stepper motor machines, lathes and mills. Nothing really complicated, pretty low cost machines. And so as soon as Jason came on board, and this is just kind of a funny part of the story, we had just got back from IMTS 2016.
Okay.
That was my second trip there. This is his first trip. And, it's just kind of overload if you've never seen all
I know. This year was amazing, I thought, with all the robotics and everything.
Yeah, it was just awesome. I love that show. It's one of my favorite things to do, and just love going there.
Yeah.
Last time I was there with Jason and one other person, and we were there for basically a little over little over half the day because we got stuck in traffic on our way there. So we had to hit the floor till like 10:30, 11 o'clock. It's terrible. But after IMTS, we ended up buying our first CNC machine. And this was kind of fun because Jason had never touched a CNC machine before, right?
What was his background? What was his training?
It had nothing to do with machining. He just had purchased this South Bend lathe and worked on it a little bit because he wanted to basically turn some parts. Of course, it's a 2-axis manual lathe, right? Very simplistic.
Yeah.
But good quality machine, right? Made back in the 50s. So we decided we're going to go after it. He's like, I can learn G-code, he says. He's like, well, I think you can. I had a little bit of CNC experience from this little benchtop CNC I bought like 7 or 8 years ago just to make some parts for some toys I was working on in my basement.
Interesting.
Definitely not production. And about a week or so later, we got a follow-up call from Ganesh, one of the booths we visited, and a rather pushy salesman that said, "Come on, let's fly out to California, meet the owners, and show you the equipment. We'll get you going." And it was between them and Star were the first 2 machines that we're really considering.
Okay.
We ended up going with the Ganesh because it was a lower cost machine. If I could do it all over again, knowing what I know now, I probably would have went with Star because I think it would have been a little bit higher quality machine. Probably make the parts a little bit faster, probably get a little bit better support. And that's not to talk negatively about Ganesh, but I think
they look really slick too. They have a nice aesthetic.
Yeah, they look all right. But I think what their main objective is to provide a very low-cost machine.
Yes.
In that category. And so you're missing some of the other things that you find, I think, with some of the higher-end, more well-developed companies like Star and especially like Traub and Index. But anyway, so went out to California, met with them, and while I was out there, I said, well, we're having CNC school next week. It's like, well, my guy doesn't really know how to program a machine. It might be nice if he could participate. So, well, send him out here. You can come on out. So I call him up that day. This was Friday. He said, hey, Jason, you want to fly out to California on Sunday and go to CNC school next week? And his answer was, sure. So bought the plane ticket that night, flew out there, and went through school. We ended up buying that Ganesh. And this is after we had made the purchase but hadn't even taken delivery of the Tormac yet. And so our first CNC machine actually hit the floor just a little over 2 years ago in September of 2016.
Okay. It's funny how the series of events which
exactly
creates decisions.
So we got that Tormac on the floor. Jason got back from CNC school. He started programming that thing, and we started making our own parts. And it took us a little while to get all of our stuff in order to purchase that Ganesh, but we did that. That arrived in December, and we got 3 days of training on it when it arrived. And other than that, it's just between Jason and myself, I'd say a lot more Jason than me. Learn that machine inside and out, learn how to make it sing, and
wow,
off we went.
Was the support must have been pretty good from them?
Not really. Not really. No. I think
where was Ganesh made?
I think they're made in Taiwan.
Okay, that sounds right.
Yeah. But I think the Star machines are too.
Yeah, they maybe made some in Japan.
Maybe some of the parts might be made in Japan, but I'm pretty sure the machine is assembled in Taiwan. And
have you been to Taiwan?
No, I have not.
Oh man, I went to Taiwan one time in Taichung, which is like the machine tool capital of the world. There's just thousands or hundreds of different machine tool companies. So many of them are made there. The Mecca.
Oh, I bet it's just absolutely amazing.
It's interesting.
What I'm hoping that we'll be able to do is, I'm really looking forward to maybe visiting Index in Germany.
Oh yeah, that would be really neat.
Yeah, I think it'd be really interesting to see, where they're actually making these high-end machines that are going to end up getting knocked off and copied over in Taiwan.
No, yeah, these are not going to be copied in Taiwan.
You don't think?
No, not an index. No. Uh, it's sure they can make something, but it's no. This is one that it's just an imitation.
Okay.
Um, I'm not German, but but I can tell you after seeing all, I've seen a lot of different Swiss machines and screw machines, and you know, who knows? Who knows what they're capable of? But I don't think so.
Okay.
But in any case, let's go back to we were talking the last time about market share,
Sure.
and what your I mean, we just touched on this, but what's your plan? Do you have like a 5 year forecast? How much you guys expand? What are you doing right now as far as like shipping worldwide, etc.?
Well, our 5-year plan is pretty vague at this point.
Mm-hmm.
Best way to summarize it is we're looking to grow, and we're looking to grow as quickly as we effectively can. Because unlike an index, our products are a little bit more simplistic, and I think the risk of them being knocked off is much, much higher. And
Yes.
so our perspective on that is our best defense is a good offense, and that is to scale up our operation as quickly and as efficiently as we possibly can, make as many as we possibly can, and at the same time, this is where the whole Traub and index thing comes into play, to scale to compete with the capability of the mass manufacture of China. To think that you can do that in the U.S. is maybe just a little bit far-fetched.
Yeah.
To scale with machines that are extraordinarily complex and capable of making extremely high-precision, very intricate things.
Right. That is one way to try to.
At least slow them down,
Mm-hmm.
right? And at least on top of that, maintain a little bit of a differentiator that they may be able to knock off the design and make an overly simplistic version of it. That may still function, maybe even comparable, but it'll clearly not be the same thing.
Yeah.
And I'm hopeful that between Traub and Index, we're going to be able to make something that is much more challenging to accurately duplicate in mass production.
I see. So you want to stop people from being able to duplicate it.
Well, or at least make it difficult. Where if you're going to mass produce a knockoff of our product, you're going to have to step up your game and invest in the kind of manufacturing infrastructure that we are.
Mm-hmm.
And $200,000 Ganesh machines or whatever you're paying for your Taiwanese, dual spindle machines, or stepping into $1 million or multi-million-dollar multi-spindle, with 35 or 39 axes of NC control. You can't even really compare the two.
That makes sense. That makes sense. I think that is the calculation of a lot of people here, that's how they can, or in Europe, that's how they can stay ahead.
Well, what other choice do we have? I just don't think it's practical to think that we can scale up mass production of simplistic things to compete with China. I mean, they've got access to cheap, machine tools. They don't hold tight tolerances, but they hold pretty good ones. But they also have very cheap labor and very cheap access to materials. I just don't see it being practical, especially.
Why do you need such tight tolerances for?
Well, see, that's the beautiful thing. Why do you need them? To a certain extent, they're necessary in order to maintain the right fit, finish, and feel of the product. Okay? So when you look at any high-end thing, right? Take a Swiss watch, for example. Do you need tight tolerances to manufacture it? Sure you do. Now, do you need tight tolerances to make a digital watch? Well, a little bit to make some of the electronic stuff that are just made by the millions. But the reality is the electronic components are much more simplistic to manufacture and to mass produce than the extremely high precision mechanical components of a Swiss watch. So part of the reason we need tight tolerances is to reduce the propensity of our devices for duplication, right?
Yeah.
And secondary to that, to maintain the right fit, feel, and finish, that our customers are willing to pay for to get that premium product, and to know it's not just some, ugly mass-produced thing that was made on an antiquated piece of equipment in a mass production facility in China.
Okay. Well, it sounds like a good philosophy. I was just curious. It's not like you're doing surgery with it.
Not yet. But, at the same time, something else I've learned on we'll just call it my relatively short journey in this industry,
Mm-hmm.
In terms of just the product development and making of things, is that it seems like time and time again, once you have access to technology, and I'm not just talking about myself, I'm talking about nearly everyone having access to technology, and more specifically, everyone in our company here. Just taking the 3D printers, for example, it becomes a game changer because now all of a sudden we're utilizing this tool in ways that we hadn't even imagined before we had it available.
Okay.
And all of a sudden it changes your perspective and it accelerates the development curve, and now the product tends to start traveling a path in a slightly different direction than you would have anticipated a month ago, 6 months ago, before this equipment was there. So with a Trob or with an Index that has significantly higher functionality and capability, not to mention capacity,
Yeah.
it gives us the option to try things that would not be physically feasible in a lesser machine,
Yeah.
allowing us to continue the evolution of pushing the mechanical envelope in terms of what is realistically possible for mass manufacturing.
Well, I'm intrigued. I'll definitely have to come see the operation, and I'm intrigued by, what it sounds like you have some, not to make a pun, but, the gears are turning in your head for some interesting plans.
Definitely looking to keep the evolution going and to keep it interesting, not only for, the people that work here, but also our customers. And that's, another thing that I think having, again, access to higher technology equipment, it enables us to continue to produce new components and accessories for our devices to not only maintain a visual and an interest level engagement with our customers, but also to maintain a purchasing level engagement, because when you're buying devices and components that generally don't break,
Yeah.
well, the only way to keep a customer coming back is to keep them interested and to continue to make new things that at least look different, if not perform better or differently.
Mm-hmm. Well, no, the concept is great that there just aren't very many moving parts, or any really. So, but there's a great irony of using the most complicated machines to make a very simple machine. But it makes sense.
I just find it comical. But at the same time, it's also very, very gratifying, to think that, yes, we're going to use this extraordinarily complex, one of the most technologically advanced CNC machines available today to make these silly little devices that aren't a whole lot different than rolling papers.
But I mean, what's interesting to me is it appears you have such a fascination with the technology. So it kind of makes me think there's a part of you that would like to make a complex product.
Oh, are you kidding me? What would be better? That's again just like the 3D printers, and you'll see that if you come in for a visit. Initially, I bought one because I thought it might be a useful thing to have. I used to use a MakerBot that a friend had, and it was kind of fun, but it was such a pain to use. And so I had one of my main guys, R&D guys. His name was Joe. He ended up taking a job and moving to California and working for Tesla now. So kind of miss that guy.
Yeah, it must be sharp.
Super intelligent guy. I mean, extremely motivated. This is the kind of guy that it wouldn't be shocking for him to be working 60 hours a week because he wanted to.
Mm-hmm.
Okay? Don't really ask people to put in overtime here, but we make it available to them, and most people take it. And so I said to Joe, hey, let's get this printer. I think it might be useful. You can kind of take it home and play around with it. He said, oh, I don't know what we'll use it for, but okay. And it took a little while for him to kind of get it dialed in and functioning. And within about a week of him getting the printer functioning, he's like, well, that device that we're working on for, trying to make some jigs and fixtures for streamlining our assembly process. So, you can print that. And all of a sudden the lights start going off. And right now, we have, we'll just say more than one 3D printer, so that we don't have to worry about if one of the people in our department here needs to make something that, well, the printer's in use and got to wait your turn. Because that kind of down progression. And so we print a wide range of different parts for holding tools at workstations and assembly stations, as well as printing parts for some of our automation equipment that we're working on.
Well, so you clearly believe in complicated products, but do you have any desire to make a different type of product that has a lot of different parts inside that's more complicated?
Absolutely.
Uh-huh.
And one of the biggest holdups in doing that is simply getting to the point where we can consider ourselves as a company to be infrastructurally stable, where we have sufficient infrastructure to manufacture sufficient products to at least meet at that point in time and the near future's anticipated public demand for our products, so we don't leave a gap in the market, and still have enough available manufacturing capacity to do our R&D and our development, and then make some or further development of some of the concepts that we have and some of the prototypes that are already put together, and get them ready for manufacture.
Okay, so you have a lot of other ideas of stuff you want to make. I mean, I would hope so if you're going to buy an MS-22.
Eventually. Yeah, our goal is not to keep our machines busy and sell as much product as they're currently making. Our goal is to continue the scaling, because when we look at what the global market is for these types of devices, especially as the markets are changing and evolving, with
I think it's an absolutely good place to be selling something. It sounds like a better business than ours.
Well, there's always room for collaboration here, so just more fun stuff for us to be thinking about.
You never know. Is there anything you'd like to add before we wrap this up? I do plan on coming down and doing a follow-up, and I did a little research about you, and I have a lot of questions and things I want to learn about. But do you have anything else to say to the American people, or the world, for that matter?
The biggest thing that I like to convey to people, if they're at all interested in knowing or listening, is that as a small company, our goal is to provide good quality jobs and to really provide anyone that's interested in our products, hopefully, a much better alternative to what they're currently doing or using to smoke.
Well, I'm looking forward to receiving one.
Well, and hopefully you'll have it next week. I think we got your package just about all put together. It should go out in the mail, if not today, on Monday, and you should have it by the end of the week.
Oh, fantastic. That should be great. Really appreciate it. Thank you.
You're very welcome.
Well, George, I really appreciate you being on the podcast, and I have a feeling we'll be keeping in close touch the near future.
Well, perfect. Thank you, Noah.
Oh, you're welcome. Have a great weekend. Thank you.
You too.
Bye.
Bye.